This is going to be another longer video. We're going to be talking about solving percent problems. There are a lot of different types of percent problems, so let's get started. With our percent problems, we start with the basic formula, amounts equals rate times base. What does that mean? Your rate is your percentage. If you prefer using the formula A equals P times B, where P is the percentage, that's fine too. You can write that in your notes if you want. A equals, that's not supposed to be an arrow. A equals percent times base. So base is your original amount. So base is your original. Your rate or percent is going to be the percent. A is your final amount. So you have an original amount and you have a final amount. A is going to be your final amount, B is your original amount. So let's take a look at problem 37 together. What is 9% of 350? So we have a base of 350. That is our original amount. We're trying to figure out what 9% of it is. So A equals 9%. And now remember, when we are doing these problems, we have to write our percent as a decimal. Do not keep your percent or you're going to end up with a larger number for your amount than you do for your base. And we're only looking for a fraction of it. We're only looking for 9%. So convert that into a decimal times base, which is 350. So let's see what that is in our calculator. It's 31.5. Another way to write the same question, or a similar question, 30% of 75 is what number? So our base rate is 75. We're trying to figure out what 30% of it is. So A equals, again, write your percent as a decimal. So what's 30% times 75? 22.5. Find 13.5% of 500. And that's our third way of asking a very similar question. So we're still looking for our amount. We have a base and we have a rate or a percentage. Turn that percent into a decimal. And we'll go ahead and put that in our calculator. And we get 67.5. So here's an actual word problem with percentages. Suppose you buy an electric drill with a retail price of $109.97 in a city with an 8.5% sales tax. What is the amount of sales tax going to be? So we have the original amount and then we have the sales tax. So we need to find the amount of sales tax. That's going to be our A time, which is equal to, turn your percent into a decimal, times 109.97. What's our sales tax going to be? $0.085. $9.35. Whenever you see a dollar amount, Make sure you round to the nearest cent. Nobody is ever going to pay a fraction of a cent. So we can say $9.35. How much do you pay in total? So we have the sales tax, we have the original amount, we just got to add them together. So we'll take that amount, add 109.97, and we get 119.32. Now, I would recommend pausing the video at this point and working through the student-led example. All right, I'm assuming you've worked through the student-led example. I really want to make sure you guys are working through these because the only way you're going to get good at this is with practice, and this is going to be a no-pressure situation. You're not graded on this other than with class participations. Pass, fail. If you get them wrong, you still get credit. Here's a reminder of what we can translate from words into algebra. Remember, is means equals, of means multiply, and what means a variable. All right, we are still working with A equals R times B, amount equals rate times base. Now we have different things to find out. We're going to try to find the rate. So looking at number 1, 56 is what percent of 60? So let's read this, looking at our algebra words. 56 is means equals what percent, x percent, of 60. Whenever you see what, you can think x. Solve for x, we'll divide both sides by 60. And let's see what we get x equal to. Remember, x is a decimal here. We're going to have to convert it to a percent. 0.93 repeating. What percent is that? We'll have to move the decimal place twice, and we get 93.3 repeating percent. What is 3 repeating? Do you remember? Do you remember how to figure it out? If you don't, take a minute, look back in our repeating decimals section. If you happen to know what 3 repeating is off the top of your head like I do, that's fine too. That's going to be the same thing as 93 and 1/3%. I will not be giving any credit if you say that it is 0.3%. It is not. It is 1/3%. Make sure you're converting your repeating decimals correctly. Let's look at the next one. What percent of 120 is 45? So what percent of means multiply, 120 is means equals 45. We'll divide both sides by 120 and solve for x. So x equals 45 over 120, which is 0.375. And now we have to convert this into a percent. So we have to move our decimal 2 spots, and we get x equals 37.5%. If we wanted it as a fraction, 37.5%. Either of those would be acceptable. So let's take a look at how we can find the base. We're going to be doing the exact, very similar idea here, only instead of looking for the percent, we are looking for the base. $50 is 2% of what number? $50 is means equals 2%. Remember, make this a decimal. Of what number? What being x? Ooh, we are zooming out and I don't know why. Pardon my crazy computer. I do not know why it's so crazy. All right, so let's take both sides. We divide it by 0.02. And we get x equal to, let's take a look. 50 divided by 0.02. 2,500 is our answer. And it's dollars. %5 of what number is 36? So 5% as a decimal, 0.05 of what number is 36? We'll divide both sides by 0.05. Let's see what we get x equal to. 720. All right, some real life wordy word problems. An 18% tip will be added to a dinner that costs $107.50. What is the amount of the tip? I'm not sure what this is. We can cross it out. So what is the amount of the tip? So amounts, our new amounts. A is going to be 18% of our base amount, $107.50. So let's go ahead and put that into our calculator. Our tip is going to be $19.35. University of Oregon's women's basketball team made 13 of the 29 three-point shots they attempted during the game against UNC. What percent of their three-point shots did the team make? So the amount is 13. We're looking for the percent, and the base, the original amount, was 29. That's how many that they made. That was their base. So x equals 13 over 29. So what is 13 divided by 29? That is a crazy number. However, we have to make it a percent, so let's multiply it by 100. And we get about 44.8%. "45% of the people surveyed answered yes to a poll question. If 180 people answered yes, how many people were surveyed altogether?" So now we're looking for the base. We have the amount of people that said yes. We have the amount that is 45%. Remember to turn your percent into a decimal. Now we have to solve for x. We'll divide both sides by 40.45. $180 divided by 0.45. And we get 400 people total. Now, we are also going to be seeing problems where we're dealing with percent increase and percent decrease. So, to find a percent increase, subtract the two numbers and find the amount of the increase. Using the result, put that over the original number. Make sure you're using the original number. A lot of people forget and put the new number. It has to go over the base, not the amount, to find the unknown percent. The price of a candy bar increased from $0.89 or 89 cents to $1.39. By what percent did the price increase? So we're going to take the new, subtract the old, and put it over the old, the original. So let's see what we get. It's a 50 cents. That's a lot. 0.89. That's about so we have to multiply that by 100 to get our percentage. A 56.2% increase. That's a lot. Might have to cut candy bars out of my diet if that's the case. Population of Portland in 2010 was 583,793. Estimated population in 2019 was 654,741. Find the percent increase of the population. So we'll take new minus old, and divide it by old. And let's see what we get. 654, 741 minus 583, 793 equals, and divided by our old, 580, 793. And we get that times 100 to get our percentage, 12.15%. Similarly, we have percent decrease. We're going to take the two numbers, the new minus the old, divide it by the original number. We're still dividing by the original number, and you will notice that your percent is going to have a negative sign in front of it. And that's perfectly okay, because that is a price decrease. Decrease means subtract. Price of a candy bar was reduced from $1.39 to 89 cents. So we'll take $1.39 minus 89 cents over the original, which is $1.39. Now remember, the original here is $1.39. It's being reduced to 89 cents. That's going to make it different than the one we did previous. Times 100. And we get a 36% decrease. All right, let's look at our next one. The number of students enrolled in Clackamas Community College decreased from 7,439 in summer of 2019 to 4,791 in summer of 2020. Gee, I wonder why. Find the percent decrease in enrollment. So we take the original, 7,439 minus 4,781, and divide it by the original. Times 100, and we get 35.7% decrease. Now, I told you this is going to be a bit of a longer video, so let's take a look at another section. We're going to talk about relative error. So we have 3 different vocab words here. We have expected outcome, absolute error, and relative error. Our expected outcome is what we would think would happen in a perfect world, all things being what they should be, perfection, utopia, what have you. So if we're talking about how a candy bar should be exactly 5 inches long, we know that in the real world, it's going to vary a bit. But in a perfect world, it should be 5 inches long. Absolute error is the difference between what that candy bar should have been and what it actually is. The relative error is the percent difference. So we'd already talked about percent difference in the last 2 sections. So now we are talking about the relative error, the percent error. That's going to be a percentage. So we're going to subtract the 2 numbers. We're going to subtract the expected outcome from the actual outcome. That's going to be our absolute error. We're going to take our absolute error and divide it by our expected outcome to find our relative error. So let's take a look at this. A window screen is measured to be 25 and 3/16 inches wide instead of the advertised 25 inches. Determine the relative error and round to the nearest 0.1%. So it's bigger. We'll take our new or our actual, subtract what it should have been, divide it by what it should have been, and that'll give us our percent. So that'll give us 3/16 over 25, which is the same thing as 3 over 16 times 1 over 25. Let's put that in our calculator. 3 divided by, in parentheses, 16 times 25, end parentheses, equals, it's pretty small, but that's just the decimal. We have to multiply it by 100 to get the percent, and it is 0.75%. The contents of a box of cereal were supposed to weigh 10.8 ounces, but are measured at 10.67 ounces. Determine the relative error, round to the nearest 0.1%. So we'll take what actually happened, subtract what should have happened, divide it by what should have happened, and see what we get. Grab our calculator. 10.67 minus 10.8 equals, divided by 10.8. Now that's the decimal. We need the percent, 100. And this is what I was talking about, where You should not be freaked out if you get a negative percent. This just means that it is 1.2% less than what it should have been. If it was positive, it would have weighed more, but this box of cereal weighed less, so we expect a negative number. That's perfectly okay. So negative 1.2%. We have tolerances. Tolerance is the maximum amount that a measurement is allowed to differ from the expected outcome. So that's putting a limit on our absolute error. So let's take a look at these US Mint examples. A US nickel 5 cents weighs 5 grams with a tolerance of plus or minus 0.194 grams. What's the lowest acceptable weight and the highest acceptable weight? So this just means the highest acceptable weight is going to be 5 grams plus 0.194. Lowest acceptable weight is going to be 5 grams minus 0.194. So highest is going to be equal to 5.194. Lowest is going to be equal to, I'll do the calculator, I don't trust my brain, 0.194, 4.806. Determine the relative error for a nickel that weighs 5.21 grams. So it's supposed to weigh 5, but it currently weighs 5.21. Minus what it should be divided by what it should be. It weighs more than it should, so we should get a positive number. Remember to multiply by 100. 4.2%. It's 4.2% larger than it should be. If you'd like to, you can take a moment to work on problem 45. It's going to be very similar, but we are going to move on to this problem, finding the base after a percent increase or percent decrease. So if a number is increased by a percent, add that percent to 100, and we will use that result for R. Let's take a look at some examples. A sales tax of 8% is added to the selling price of a lawn tractor, making the total price $1,402.92. What is the selling price of the lawn tractor without tax? So what this is saying is that if we take whatever the price is and add 8%, we get $1,402.92. So we don't know how much it costs, so we don't know how much 100% of it is. But we do know what 108% of it is, right? We don't know how much Y is. We don't know how much 8% of it is. X plus Y equals 108%. So what is 108% as a decimal? That's going to be 1.08. So our new is $1,402.92. If we multiply our base times 108%, we're going to get this number. So 108, or 1.08 as a decimal, times our base, which we don't know what it is going to give us $1,402.92. So X is our base, Y is our tax. but we know that both together are 108%. So let's divide both sides by 1.08. Let's do that on our calculator. $12.99 is the original price. Let's use similar logic to do the next problem. U.S. population in 2018 was estimated to be about 327.2 million, which represents 7.6% increase from 2008. What was the U.S. population in 2008? So pop in 2008 is going to be our 100%, and we don't know what it is. Our population in 2018 equals the population in 2008, which was 100%, plus the percent increase. So the population in 2018 is 107.6%. What is this as a decimal? 1.076. Now you should be keeping this whole thing in mind when you see numbers that say percent increase or percent decrease. So don't worry about this unless you see the word increase or decrease. What is the US population in 2008? So we know that the 2018, the new, is 327.2 million equals 1.076, whatever it was in 2008. Divide both sides by 1.076. So the original was 304.1 million. All right, if my computer will let me, we will move on to the next examples. Now we're going to look at percent decrease. This is going to be the last section for this video, so just hang in there for me. All right, a city's department budget was cut by 5% this year. If the year's budget is 304 million, what was last year's budget? So last year's budget was 100%. This year, we took last year's budget and subtracted 5%. So this year's budget is 95%. So our this year's budget is 3.04 million, which equals 0.95 times x. Divide both sides by 0.95. And let's see what we get. Should be a bigger number. Yes, 3.2 million was the original. CCC's enrollment in summer 2019 was 9,116 students, which was a decrease of 2.17% from summer of 2018. What was the enrollment in summer 2018? So summer 2018, or 2018, sorry, is 100%. 2019 decreased 2.17%. So it is going to be 100 minus 2.17, 97.83%. So our most current is 9,116 equals 0.9783, because we have to turn that percent into a decimal, times x. Divide both sides by that decimal. And let's see what we get. We can't have a percentage of a student, so we're going to round to the nearest student. 9,318, which is larger than this year's, so that is a reasonable solution. Last problem, and I'll give you a break. An educational website claims that by purchasing access for $5, you'll save 69% off the standard value. What is the standard price? An educational website claims that by purchasing access for $5, so standard price was 100%. New price, we're saving 69% off, so it's going to be subtracting 69%. So that's going to be, hey now, 31%. So they're saying that $5 is 31% of the original. So we'll divide both sides by 0.31. And we'll say $16.13 because we round to the nearest cent when we're talking about dollars. What a deal. All right, that is it for this video. Go ahead and work on the student-led problems if you haven't done so already. And next we'll be talking about common formulas you may see in your program.